we are going to go over branched hydrocarbons. So this is section 14.2 in the organic chemistry unit. So sometimes you might see it as IUPAC name. Okay, so this is how we name organic compounds. So the IUPAC is like a standardized system that is used. This first slide is just kind of a bunch of the rules of how to name these branched hydrocarbons. So branched means that separately from what we were looking at before, like let's say we have a hydrocarbon like this. Okay, so this just shows one continuous hydrocarbon, let's say. So there's no other branches. Notice how for this one, we have kind of carbons coming off of here and here. So when we were looking at them before, we just look at the number of carbons that there are. So this one, there's 2. So we would use the prefix F. And because they're all single bonded, this would be ethane. Okay, but sometimes things get a little bit more complicated when we can have different groups and different smaller branches grouping off from that hydrocarbon. So I'm going to go through this first example and then we can go through step by step other examples. So down here's a branched hydrocarbon, and just so you know that anytime there's these lines that are off of carbon and there's nothing attached to it, assume that they are all hydrogens. Okay, so you can draw on the hydrogens or you don't have to. The reason is because sometimes these hydrocarbons can get really large. So writing in all of those hydrogens kind of becomes unnecessary. So we just know that all of these would be filled with hydrogens wherever we have these lines. So the first thing I'm going to do is name the longest continuous chain of carbons first. Okay, the longest continuous chain is also called the parent chain, which I'll refer to it as. Okay, the parent carbon chain. So the parent carbon chain for this branched hydrocarbon is here. Okay, so it's continuous, it's the longest one, it's 5 carbons next to each other, so we call that the parent chain. Okay, so on my parent chain, I have 5 carbons. So using table P, 5 carbons has the prefix pent. And then when deciding my ending for that, I have to notice that there's a double bond in this hydrocarbon. So that would make this pentene, okay, to represent that double bond between those 2 carbon atoms. Okay, next I want to identify these shorter chains or branches. So these are going to branch off of that parent chain that you identify. So we have 2 in this one. We have this and we have this. Okay, so notice that these 2 in this example are both exactly the same. It's just a carbon attached to 3 hydrogens like this. Okay, so we call this a methyl group. It's methyl because it's just 1 carbon. And then any group that branches off from our main parent chain gets this ending YL, and we pronounce that, like in this case, methyl for 1 carbon. So we have 2 methyl groups here. So we can start out by writing our name. We always want to put the names, we want to name the groups first. However, we need to be able to identify where in the chain they are. So we have to label or number the carbons in that parent chain. But we always want to make sure that we do so that they're numbered, the branches are numbered as low as possible. Anytime you see a multiple bond, so a double bond or a triple bond, you want to consider those as being like a branch as well. So we're actually going to start numbering from this carbon here. So we'll call this carbon 1. This is carbon 2, carbon 3, carbon 4, and carbon 5. So we'll start by naming our branches first that I have highlighted in orange. So on the 3rd carbon of the parent chain, so I write 3 dash, I have 2 methyl groups. So I call that dimethyl. Okay, I put a di because that tells us that there is 2 of those CH3s attached to the 3rd carbon of the parent chain. Okay, next, I want to make sure if you have a multiple bond, like a double bond or a triple bond, you want to identify which carbon that is at. So in this case, we can say that it's in the lowest number that it is. So we would say that it's at the 1. So the first carbon, pentene. You fill in that pentene over there. Okay, so this is telling you that we have a parent chain with 5 carbons, highlighted in green. Then at that first carbon, there is a carbon-carbon double bond. Then we have 2 methyl groups, so 2 CH3 groups, both off of the third carbon in that parent chain. Okay, so that's what this name is telling us. So these little branches that I was referring to, or these shorter chains that branch off from that parent chain, are known as alkyl groups. Okay, so that's why they end with the YL. So any smaller chain that branches off from the parent chain, you would change the ending to the YL. So here we have 2-methylpropane, 2-methylhexane, and 2,5-dimethylhexane. So all of these are examples where we have methyl groups branching off from that main chain. Again, meth is a prefix for 1 carbon. So methyl group would be a CH3 branching off from that main chain. Okay, so if I were to quickly highlight where those parent chains are of the hydrocarbons, I could see that in this first example, there's a methyl group off of the second carbon. For here, there's also a methyl group off of the second carbon. And then for this last one, 2,5-dimethylhexane, because it says di, that means we have 2 of those same groups. One of them is off of the second carbon, and the other one is off of the 5th. Okay, so you can pause that and take a look at it, but we'll go through more examples. Okay, so first example is this hydrocarbon here. So first step, find the longest chain of continuous carbons, or in other words, the parent chain. Okay, so the parent chain would be here. Okay, so this is 7 carbons. Okay. Now, the parent chains don't always have to be in a straight line. Like for example, if this happened to be the longest continuous chain, this would be fine. Okay, continuous meaning that the carbons are all bonded to each other. However, in this example, this one is only 6 carbons, so this would still make going straight the longest chain with 7 carbons. Okay, so we found that longest continuous chain. And determine what kind of family it is. So in this hydrocarbon, we have single bonds only. So it would be an alkane, so it has to have that ending of ane at the end. Now, because we have 7 carbons in that parent chain, we would look at table P, find where it says number of carbon atoms is 7. So that would give us the prefix of hept for 7, and then ane. Okay, so this is going to end with heptane. Third step is to number the carbons in the main parent chain, starting with the end that will give the alkyl groups the smallest number. Okay, again, these alkyl groups are the smaller branches that are coming off of that main chain. And we have 3 of them in this case. So we have this one, we have this one, and we have this one. Okay, so we want to start numbering our parent chain. So the alkyl groups are branching off from the lowest numbered carbons. So in this case, we have to start from the right. So we label this one carbon 1, carbon 2, carbon 3, carbon 4, 5, 6, and 7. Fourth step is to add numbers to the names of the alkyl groups to identify their position on the chain. These are prefixes that end with the YL ending. Okay, so any of the branch chains will end like this. So let's just label all of them. So this first one coming off of the carbon 2 is just one other carbon. Okay, and using our prefixes, we know one carbon is going to have the prefix meth. And then we just add the YL at the end. Okay, so a CH3 is called a methyl group. Now this one off of the third carbon of the parent chain is the same thing. It's another methyl group. This last group is off of the fourth carbon of the chain, and there are 2 carbons. So with 2 carbons, we use the prefix F. So this would be called an ethyl group. Step 5 is to use the prefixes to indicate the appearance of a group more than once in a structure. So sometimes you can have the same kind of alkyl group more than once off of your parent chain. So you have to make sure that you label that. So in this one, we do have 2 methyl groups. So that's the same kind of alkyl group where we have a carbon attached to 3 hydrogens. So because there's 2, we have to make this dimethyl when we write the name. Okay, because di means 2. So let's say we had a third one. If we had a third methyl group, we would start it with tri and so on. The ethyl group we don't have to change because there's only one of them there. Then we have to make sure that we list all of these names in alphabetical order, making sure to do your alkyl groups first, and then you can name your parent chain. So let's start that out, and then trying to go in alphabetical order. So di, so D comes before E, so we'll start out by naming the methyl groups. So we always start out with the number carbon that those branches are coming off of on the parent chain. So we have one methyl group off of the second carbon, the other one's off of the third. So we label this 2-3, or 2,3 dash dimethyl. We can use another dash. Now we're going to add that ethyl group. That ethyl group is coming off of the fourth carbon on the parent chain. So we put 4-ethyl. Dash again, and then the last part is we want to label our parent chain. So we double check, make sure there's no double or triple bonds, and we don't have any of that. So we're just simply adding heptane. So this is 2,3-dimethyl 4-ethyl heptane. So let's look at another example. So in this one, it shows that there are no like actual branches or alkyl groups off of the parent chain. So the parent chain we can highlight here. So it's the longest continuous chain of carbons. Okay, we'll notice that there aren't any other groups or like shorter chains branching off. However, we do have this carbon-carbon triple bond. Okay, so to start, we will count how many carbons are in the parent chain. So we have 1, 2, 3, 4, 5, 6. So if we have 6 carbons, using our table P, 6 carbons is hex. Okay, so we have hex, and then because we have a triple bond present, we write hexine. Okay, so Y-N-E tells us there's a triple bond in here. Okay, but because the triple bond could be anywhere, so just by looking at this name, we're not able to tell which carbon, which number carbon in the chain it could be. It could be, you know, what if it was there? What if it moved over here? You know, we don't know where that triple bond is, so we have to label it as we do, as if it were a group. So we have to label our, or number our main branch. Okay, making sure that our multiple bond or even our groups you want them to be at the lowest number carbon possible. For this example, you could have went either way and it would have been still at the third. Okay, so all we're doing to the hexine is we're adding a 3 dash in front of it. Okay, to tell us that we have a 6 carbon chain where we have 1 double bond at the third carbon. Okay, here's another example that combines both things. So we have a multiple bond and we have branched groups or alkyl groups. So we're going to find our longest continuous chain, our parent chain, okay, which will be this one here. Okay, if there is a multiple bond, you want to make sure that that is included in the chain as well. Okay, then we can also highlight the groups we have. That's what I like to do. So we have one group there, another group there, and we have a third big group up here. Okay, then we can number our parent chain in green, making sure that we have the carbons that our alkyl groups are coming off of as the lowest numbers possible. So we're going to start over on the left instead of the right. Carbon 1, carbon 2, 3, 4, 5, 6, and 7. Okay, so we have 7 carbons in this chain. So 7 has a prefix of hept. Okay, and then we have a double bond, so this is going to end in ene, so be heptene. Okay, then we can go ahead and label our alkyl groups. So these first two on the left are the same. Again, they're the CH3 groups. So anytime there's one carbon, they have the prefix meth. And then all the branch groups have the YL. So these are 2 methyl groups again. Group. Okay, then this one on the 4th carbon has 1, 2, 3 carbons attached to it. So 3 carbons has the prefix prop. So this will be a propyl group. Okay, now we can start labeling. Again, because we have 2 methyl groups, we want to make sure that we label this as dimethyl. So those methyl groups are on the 2nd and the 3rd carbons of the parent chain. Dimethyl, because there's 2 of them. All right, then we're going to label that last group, which is the propyl, which is 3 carbons. And that's coming off of the 4th carbon of the parent chain. So we label that 4-propyl. Okay, then lastly, we want to add this heptene, but we have to make sure we indicate where that double bond is on the parent chain. So we say it's the lowest number, so it's at the 2nd carbon. So 2-heptene. So the name of this molecule is 2,3-dimethyl 4-propyl 2-heptene. So telling us that on the 2nd and 3rd carbon of the chain, there are 2 methyl groups, so 2 CH3 groups. On the 4th carbon of the parent chain, there is a propyl group, okay, where there is 3 carbons attached. Then at the 2nd carbon in the chain, there is a carbon-carbon double bond. And in total, we have a parent chain of 7 carbons, which is that heptene. Okay, groups don't always have to be like methyls, ethyls, and propyls. They can be composed of other things like halogens. So halogens are your group 17 elements, like fluorine, chlorine, bromine, iodine. We also call these halocarbons. Okay, so when there's a halogen attached to a carbon in one of these hydrocarbons. And any of these can be attached to a carbon. Let's just look at an example here. Okay, so you're going to name it exactly the same way. And you also want to indicate it like it is any group. You want to be able to write the number carbon that that halogen is branched off of. So we start the same as always. We find the parent chain, the longest continuous chain of carbons. Then we also have to identify where our groups are. So we have one branch here. So that's another methyl, okay, that 1 carbon with the 3 hydrogens hanging off. Then we also have a bromine, which we call this a bromo group. Okay, this is on your reference table if you ever forget. So that's bromo. This is going to be a methyl. Okay, so let's number our parent chain. So I'm going to number them from right to left. So carbon 1, carbon 2, carbon 3, and carbon 4. Okay, I'm doing it this way because B comes before M in the alphabet. Okay, so I just want to make sure I label the bromine with a lower carbon than I do the methyl. Okay, so again, we write our groups first and identify where they are. So to start, we have on the 2nd carbon of the chain, we have a bromo. So I write 2 bromo, and then I'm going to write the methyl group. So the methyl is coming off of the 3rd carbon in the off of the parent chain. So we write 3-methyl. And then to end, we want to make sure to write what the parent chain is. So we have 4 carbons. 4 carbons has a prefix of but, and they're all single bonded, so that is butane. So this is 2-bromo, 3-methylbutane. Let's try another example. We find our parent chain, which is just these 3 carbons here. And then we find our groups. So we have this group, methyl group, and we have the bromine again. Then we want to label our chain. So this one, both of them are right on the middle carbon, so it doesn't matter which way you do it. So I just labeled them 1, 2, 3 across. Then we want to write down our groups first. So we have a 2-bromo, 2-methyl. Then there's 3 carbons in our parent chain, so that is a prefix prop. They're all single bonded, so propane. So this is 2-bromo, 2-methylpropane. Take a look at the practice questions in your packet. So this is 14.1/14.2 in the practice packet. We'll go over, these are kind of harder examples, but we'll go over how to do more. But I think it's most important for you to look at like the different multiple choice questions.